Hello, my name is Brian Frost from Applied Relay Testing. This video is an introduction to our Reflex51 Life-Test system. The Reflex51 was originally intended specifically for automotive testing, but it has since seen applications from high cycle rate read and MEMS devices through to contactors switching hundreds of amps. The architecture of the Reflex51 is interesting because it is a measurement and control system and intended to sit within an existing life-test framework. This means that in many cases you can use your existing coil and load power supplies and of course your loads. The video goes into a little detail to show how easy it is to program and the kind of information you can expect to see from the system. If after watching the video you have any other questions, please don't hesitate to get in touch with us. Thank you.
In this video, we will look at the Reflex51 Life-Test system. As you can see from the opening screen here, the display can be made very simple. Normally an operator would load a test program, run the test program, and pass and fail information is automatically logged to disk. But as we will see, it's possible to go behind the scenes and program the system for a significant scientific investigation. This diagram shows a typical life-test configuration. Here is the relay contact, shown as a changeover, a coil drive circuit here, connecting a power supply to the coil via a software-controlled switch, and load resistors and a load power supply. Contact voltage drop measurements are made here by a measurement unit. The flexibility of the Reflex51 is due to the ease with which activities during every relay cycle can be programmed. This window here represents the timing of every cycle of the relay. It's currently set to a cycle period of 100 milliseconds, so the relay will cycle at 10 Hz. Within this cycle you can see that there are two what we call time slots. One time slot is responsible for controlling the coil drive, and the other time slot is responsible for making a measurement on the closed contact, the normally open contact. Every time slot has an activity attached to its start and its end. So in the case of the coil drive, the starting activity is shown here as a small script action SW1.on. That tells switch 1 to turn on. At the end of the coil drive, that same switch SW1 is turned off, and that switch corresponds to the coil switch that you can see in the diagram here. That will turn the coil on and off. Measurement of the voltage on the normally open contact when it's closed is made by a measurement unit called M1, and at the beginning of this normally open 1 voltage drop time slot, M1 is told to start. That measurement unit then begins integrating a voltage measurement which will start here and go along to the end of the voltage drop time slot. At the end of that time slot, the measurement unit M1 is told to stop. From that point on, we have a value of voltage available called M1.value, which firstly we choose to assign to a variable called VID112, and then on the assumption that there is a 1 amp load current flowing through the load resistor, which gives us a known current through the contact load here, we can derive a second variable called CRNO1, the contact resistance of the normally open number 1 contact, calculated using Ohm's law, voltage over 1 amp of current. So far, what has been described is very similar to the operation of a standard programmable logic controller, where voltages can be measured and processed using a simple script language. Where this Reflex51 Life-Test equipment starts to add real value is in the nature of what happens to these variables. Because this window represents a single cycle in what may be hundreds of thousands of cycles of activity of the relay, new values will be created for these variables on every single cycle. The Reflex51 allows those values to be accumulated as individual results. You can see them here, VNO1, CRNO1, and each of those values has charting and analysis attached to it. You can see the effect of this when we start a new cycle run here. We're now starting from the beginning. We've so far done 70 or 80 cycles out of a possible 1 million. And you can see here the contact resistance measurement points building up as the cycling progresses. By the time we've reached around 2000 cycles, you can already see the chart building up with a significant amount of detail. If we see any interesting effects, we can zoom in a little bit more closely on them. And if I open the results up a little bit more, this is even more clear. Any of those values that we chose to assign as a result, we chose CRNO1, and we've also got the voltage drop available as well. Any of these result values are now available as a summary with min, mean, maximum and standard deviation, a line chart over the entire life test cycle, a distribution, and individual values for every cycle. This simplicity of a single normally open contact can quickly be enhanced by the addition of more testing. For example, we can test the normally closed contact. We can create a time slot for that and make our normally closed measurement somewhere in this region here when we are expecting that contact to be closed, and we then assign some measurements to it. Measurement unit number 2, start. Measurement unit number 2, stop. And then we can create some values which we'll plot. A contact resistance for the normally closed contact equal to the normally closed contact voltage divided by the 1 amp test current. Now when we start the measurement, we will now get results for CRNC1 as well as CRNO1. So it's extremely simple to add additional contacts to the testing and to flexibly play with the calculations and the numbers in a very similar way to buying separate measurement equipment and then spending quite a bit of time doing this user interface, which we've already done for you. For unattended operation, there clearly needs to be a way of detecting for failures. Every one of these result output values can have a failure attached to it and a criteria for either stopping or monitoring those failures. CRN01, the contact resistance of the normally open contact, we can enable failure checking, and that we want the machine to stop when the failure count reaches the maximum limit, which in this case is 0.92. If we start a new test now and run that test, you'll see that one of the values has just exceeded that failure limit and has now been recorded and has stopped the machine. For an even higher level of sophistication, it's also possible to execute script actions when a failure is detected, for example to disable power supplies or take some special detailed action that you would like to take place when a failure might be detected. A powerful feature of the Reflex51 Life-Test system is its ability to work in interval testing mode. Regardless of which mode the testing is in, monitoring of every single cycle is always performed. However, when testing a large number of cycles, for example some tens of thousands or even millions of cycles, the data reporting is more sensibly performed every few hundred or few thousand cycles, because trends are still clearly visible on a graph over life test of some thousands of points, instead of having to work with data where there are literally millions of points to plot. To perform interval testing, when we program the test program, we select normal interval mode. If we then run a test, we can see that what's happening here is that as the cycles are counting up, there is a sub-count of interval cycles, and at the end of each of those intervals a point is placed on our chart. Testing is still being performed every single cycle, but data recording is being made every 1000 cycles in this case. This interval testing is useful in two ways. Mainly, it performs very useful data reduction, and in fact we've not lost anything from our data, because you can see that in interval testing mode we've got a maximum, a minimum and a mean line, which allows us to see quite clearly any single cycle that caused some issue wherever it may be in an interval. So we've not lost single cycle testing information. But with additional hardware options, the Reflex51 can also be configured to make additional tests on the relay. For example, timing tests and operate and release voltage tests. And as a result, applied relay testing is able to offer a life testing solution that generates life test duration charts for not only voltages and currents across and through the contacts, but also timing information and operate and release voltage information that can be overlaid throughout that lifetime. And of course that makes it then ideal for looking at where in the motor system or other mechanical issues that may be changing with time throughout the life test. So this has been a necessarily brief look at the Reflex 51. If you have any questions about the operation of the system or would like a more personalised demonstration, please contact Applied Relay Testing. We look forward to hearing from you.